Hello everyone, welcome in this video tutorial on modeling of disorder about crystallographic two-fold axis using the FragmentDB in OLX2. Generally, there are two types of cases. First case, when atom or atoms are exactly on the spatial position. And secondly, when the atoms are lying close to the spatial position. So let's come to the tutorial part first and then we will explain it later during the tutorial. So at this point of time, we are going to join the refinement. Up to now, all the known hydrogen atoms are refined anisotropically and we are with this model. This is a silver 1 complex with only half of the molecule into the asymmetric unit. The remaining half is generated from the first half using the crystallographic two-fold axis. If I'm going to generate the rest of the molecule, I'm just pressing the Ctrl G on the keyboard and it will grow like this. So this is a silver 1 complex. So I'm going to press escape and I'm again going to fuse and I will left with the asymmetric unit only. I am again going to press Ctrl Q so the cubics are back in the map and now I am going to proceed it further. Since it is silver 1 complex and the ligand is a neutral, so we are expecting a nitrate in the crystal lattice. For this, I am going to press this button and it will compact the structure. Now you can see there are certain cubics which are quite higher than these cubics. So if I am going to edit the RES file, then I can see there are some cubics from Q1 to Q6 which are quite higher in electron density as compared to the rest of the cubics. And these three cubics are again higher in intensity than remaining of the three cubics. So where are these three cubics? If you closely look at these three cubics first, you can find the two cubics are only half occupied. They are on the spatial position and the remaining, the third cubics on the general position. So these cubics Q1, Q2 and Q3. If I am going to press Ctrl G on my keyboard, then it will grow like this and I'm just going to press this. Then there is a formation of some nitrate like moiety here. So I am expecting this should be a nitrate molecule. And here again there is some grow and when I'm going to press it, then I am getting some strange cubics here which are not forming any known type of molecule or moiety. Okay, let's first come to this part. So for this part, it should be a nitrate. I'm going to press escape and I'm going to fuse again and I am getting these three cubics. So this should be a nitrogen and these are the oxygen. Since one of the oxygen and one of the nitrogen are on the spatial position, they are only half occupied. They are on the spatial position, they are on the two-fold axis. So remaining one oxygen molecule is generated with the two-fold axis. So if I am going to refine it as nitrogen and these two as oxygen, then it should be nitrate. I'm going to refine it, then the R factor will definitely drop down from 13% to 9.51%. So you can see from 13% to around 9.5%. And now I'm going to press Ctrl G. Then there is, of course, the third oxygen atom should be here. And the next step is, of course, I have to refine anisotropically. I'm going to select these three atoms, the two oxygen and one nitrogen. I'm going to type anis, the one nitrogen and two oxygen atom, and I'm going to refine it. and there is further improvement in the R factor definitely. Yes, the R factor is around 8.28%, but one of the oxygen is getting elongated. So this is one method. Now I'm going to control Z press, then there is nitrate. Of course, it is nitrate because these two atoms are on the two-fold axis and this is on the general position. So the two-fold axis will generate the rest of the oxygen atom from the nitrate moiety. Okay, so I'm just going to fuse it, and the other method is using the fragment DB. So first, let's look at the symmetry. I'm again going to the presentation part, and here you can see the situation is like this. In the asymmetric unit, we have only 3 atoms out of 4 atoms, out of which the 2 atoms, any one oxygen atom and this nitrogen atom is lying on the two-fold axis. So this oxygen and this nitrogen atom are lying on the two-fold axis, and the remaining oxygen will be generated by the operation 2 here. Okay, so here we can generate the rest of the oxygen atom from the crystallographic two-fold axis. Okay, let's come back to the tutorial part. And the other method to model this type of disorder, just I'm going to delete this. I'm going to refine it. Now I'm going to compact the molecule by pressing this button here. Now again, I'm going to press Ctrl G. There is of the nitrate. Yes. Now what I have to do, I am going to tools. There is FragmentDB, and I will search for the nitrate molecule here. Here is the nitrate. Where it is where is the nitrate? Yes, here it is, nitrate. Since the molecule is on the symmetry and 2 atoms are only half occupied, so I will use the occupancy 0.5 instead of 1.0, and since molecule is on the symmetry, I am using the negative part -1, and I am going to press hit. Now this nitrogen should be corresponding to this cubics, and these oxygen are corresponding to remaining cubics. So we have to match only maximum 3 atoms. First I am going to click on this atom, and then I am going to click on the central cubic. Then I am going to click on this atom, then on this peak, and now the clicking on 2 atoms will exactly fit the nitrate on the cubics. Now press escape, and I'm going to again fuse, and now if I'm going to select this nitrate, then you can see all the restraints are automatically written in the .ins file, and this is in part -1, and these are the 4 atoms, 1 nitrogen, and of course the oxygen atom with only half of the occupancy. Yes. Now the next step is I'm going to refine it by pressing Ctrl R on the keyboard, and it will refine. Now the R factor is from 13.5 to 8.25%. The next step is anisotropic refinement. I'm going to select these 4 atoms and typing anis, and I'm going to refine it, and the R factor will further down to 7.83%. Of course, it is better than the previous case in which we are modeling the disorder from the without using the FragmentDB. Now you can see all the 4 atoms are looking very nice. So I'm going to refine it. So the shift gets 0. Yes, now it is almost 0. This complete the refinement of the disordered nitrate in the lattice. Now, if I'm going to see the F observed versus F calculated graph by just pressing this percentage button, now the graph is not looking very nice. It is even scattered. So there is something we are still missing, some cubics. We have to assign, just pressing this button again, and now you can see there is some cubics intensity are here, and if I'm going to select them, then I can find the Q2 is only half occupied, and the coordinate are looking special 0.75, 0.5. So where is the Q2? This is Q3, and this is Q1 and this is Q2. It is only half occupied. Now, what I have to do, I am going to press the Control G and it will grow like this. So here there is strong strange electron density which is not forming any known molecule. But from the crystallization point of view, we are expecting some ethanol molecule in the crystal lattice. So let's fit the ethanol. Since the ethanol molecule is looking on the symmetry, so we are again using the part -1 and occupancy is only 0.5, is not fully occupied. So I am going to search for the ethanol here. This is ethanol. Let's okay, and then go to fit part -1, free variable of course 1 and occupancy is 0.5. You can use the replace mode or you can even use the residue, it's up to you. Let's this time use this residue and let's go to fit. So this oxygen should be here and this carbon should be here and this carbon should be here. So it's not going to fit exactly. Let's move it with shift key where it's going to fit. Let's move it. Just make a best fit with your practice. Something like this. It's up to your practice how efficiently you can fit. Now I think this is the best fit. Yes, okay. So you cannot fit all the three atoms just like nitrate in the previous case because this is disordered, highly disordered. So I think this is okay. So if you are able to fit two atoms out of three atoms, then it's okay. Now just press this escape button and I'm going to fuse, and now I'm going to make it anisotropic. But before that, you can see the atoms in the ins file. This time I'm fitting a residue. Now there is name resi ethanol 1. There is part -1 and occupancy is only half, and these restraints are automatically written into the ins file, and there is no need to type them manually. Now select these three atoms, type anis, then add to add the hydrogen atom, and now I am going to refine it just by pressing Ctrl R on my keyboard, and it will going to refine. Yes, now you can see there is some unwanted bond here. Just going to select this and type del bond, and now add H add 33. This should be H add 83. This oxygen, so this hydrogen should be in this direction. Okay, let's first define, then we will see. Yes, now you can see the R factor is around 4.24%, and this hydrogen I think should be somewhere here. For this, just select this hydrogen atom, go to disorder tool, and you will find there is button tab fit. Split is for the disorder modeling, but you have to press the button fit. Now select this button with your left mouse key, press shift button on keyboard and move where should it lie. I think here it is looking better. Yes, just press escape and now define it. It will take the best position. Yes, now you can see the R factor is around 4.21% and shift is almost 0 and it is stabilized. Yes, now if you look at the F observed versus F calculated graph just by pressing this, and now it seems to be very nice looking. And now this is ethanol and this is the nitrate. If I'm going to select this just by pressing shift and I'm going to type unique, so unique, and this is ethanol. I'm going to press Ctrl G, then you can see the two molecule, the two orientation of the ethanol molecule are like this. So the second orientation is generated from the first one by the crystallographic two-fold axis. Just going to press escape, type again unique, it will bring the whole molecule back, and now I am going to press Ctrl G, it will generate whole of the molecule like this. So in this way you can grow the molecule. Just going to press escape. Now just going to type fuse and we will back with the asymmetric unit. Now come back to the symmetry part. Yes, here the situation is something like this. The two-fold axis is not passing through one or more atom. It is passing through one of the carbon atom, close to the one of the carbon atom, and it will generate the second orientation like this, and this is overall molecule. So this two-fold axis, which is in this case the atom are quite close to the special position. They are not exactly on the special position. And the overall effect is like this. The two-fold axis is generating the second orientation of the ethanol molecule. So now if you look at the coordinate of these atoms here, you can see none of the molecule is lying on the special position. They are quite close to the special position. And there is, of course, if I'm going to press this button, it will compact the molecule. Then you can see the distance between this oxygen and silver just by select and type cell. The distance is around 2.8 angstrom, which could be a possibility for the silver oxygen bond. And similarly, if you select these two atoms, the distance between these two atoms, this ethanol oxygen and silver is 2.7 angstrom. This is again a possibility of the bond here. If there is possibility, you are sure there is bond, then select these two atoms and type add bond. It will add the bond. Again select these two and press add bond. It will add the bonds and now define it. Okay, so now if you press Ctrl G on the keyboard, it will grow like this in the east direction. These are the two orientation of nitrate and the two orientation of ethanol are of course there. Just press escape and you can see the coordination of silver is like around is like some 5 coordinate here. So hope it will help, and just thanks for watching the video. Thank you very much.